In the previous parts, we saw why traditional inspections often miss risk and how ground conditions place stress on pipelines over time. Inspections may confirm what is visible at a location, but they do not always explain how risk develops across the corridor. The remaining question is simple. How does better visibility actually change engineering decisions? Many inspections focus on specific locations, such as road crossings, valve stations, or areas with known issues. These point inspections provide useful local information and help engineers confirm conditions at those exact spots. However, pipelines do not experience stress only at inspection points. The ground around them behaves continuously, not in isolated segments. Drainage patterns, slope movement, and soil conditions can change gradually along the corridor over time. When inspections are limited to fixed locations, changes developing between those points may go unnoticed until visible damage or failure finally appears.
A pipeline does not exist in isolation. It operates within a continuous corridor shaped by terrain, drainage, land use, and long-term ground behavior over time. This corridor functions as a connected environment where conditions in one area can influence what happens elsewhere. Changes in elevation, surface water flow, or soil moisture upstream can gradually affect stability downstream. Slope movement in one section may alter stress distribution along the pipeline across a much longer distance than expected. To properly understand pipeline safety, engineers must view the corridor as a single system with interacting elements, not as a series of isolated inspection points.
When engineers have better visibility along the corridor, the way priorities are set begins to change in a clear and practical way. Instead of reacting only to visible damage or obvious failure, attention gradually shifts toward areas showing early signs of change. Small ground movements, subtle drainage shifts, or slow terrain transitions along the route become signals that deserve closer attention and follow-up. These early indicators help reduce uncertainty and speculation. Inspections, analyses, and site visits can then be planned more deliberately, focusing effort where risk is beginning to develop, rather than relying on habit, fixed routines, or assumptions based on incomplete information.
Better visibility also changes how inspection safety is managed in day-to-day operations. Many pipelines run through remote areas and difficult terrain, where access is limited and environmental conditions can change gradually over time. Steep slopes, dense vegetation, unstable ground, and poor access routes all increase risk for inspection teams during routine site visits. When corridor conditions can first be assessed remotely and reviewed carefully, teams do not need to be sent everywhere every time as a precautionary measure. Site visits then become focused and intentional, directed only to locations where change, uncertainty, or concern has been identified, reducing unnecessary exposure and improving overall inspection safety for personnel.
No single tool provides all the answers when it comes to pipeline risk. Ground sensors deliver precise measurements, but only at specific locations along the route. Visual inspections help confirm local conditions, yet they're limited to what can be directly observed at that moment. Broader visibility across the corridor adds essential context, helping engineers understand how conditions interact and evolve. Together, these tools support a more complete and reliable understanding of pipeline behavior over time. Pipeline safety is not only about inspecting the pipe itself, it is about understanding the environment the pipeline operates within and how that environment changes over time. When engineers can clearly see the full corridor, they are able to make better decisions, earlier, more confidently, and with a clearer understanding of risk. If this explanation was useful, you can follow the series for more practical discussions on pipeline monitoring, geotechnical risk, and engineering decision-making. Thank you for watching.